Let's kick it off. Mehran, first question for you. So let's talk about data processing frameworks. We know that there are a lot of data processing frameworks. There's Apache Spark, there's Apache Flink, and choosing the right tool for the job becomes like very important. I know that Michael mentioned that you guys love decision tree at Google. So do you have some kind of a decision tree that can help us choose the right tool?
I'm not aware that Google loves decision trees, but I will say something controversial. I strongly dislike them. Actually, my most popular presentation at Google is one that basically answers this question. And the title of the presentation is Data Flow Or. I think the shortcomings of decision trees are they're really based on yes or no questions. And oftentimes the answer to the questions you want are really around, it depends. And that doesn't necessarily make it easier, but I think about the right decision as a function of four things. Your use case, so what exactly are you building, obviously. Two, your skills. Basically, are you a Java programmer? Are you using SQL? Are you using simply just software? I think that's an important thing to consider. And then lastly, the requirements of your use case, right? We're thinking about latency, throughput, volume. All these things require different trade-offs for different technology stacks you choose to use. And there's also just kind of the basic question of do you want to build versus buy, right? Buying software is one particular offer, but we tend to really recommend customers think about platforms. So we take care of the infrastructure, and our customers actually build the cool stuff. And this is not a great answer to your question. We don't have a decision tree, but I think thinking about those things in those three ways is super important. One that you're thinking about is cost. The reality is, if you're really expert on a particular technology, you can bring the cost down as much as you possibly can, right? You can optimize the shit out of it. So I think cost does matter, and certain technologies do require a little bit more extra, but those first two are the most important ones.
Got it. No, I have this. All right. So a follow-up question on that, right? How does one? We know that there are advantages to using a fully managed solution like Dataflow and BigQuery, and some of them are very obvious, right? We don't have to manage the infrastructure. We don't have to worry about auto scaling. But what other advantages there are for choosing a fully managed service versus open source self-managing solutions?
Yeah, that's a great question. And I think, you mentioned a couple of features around auto scaling and really not having to manage infrastructure. Mm-hmm. That's incredibly important, but really the nuts and bolts of keeping a service on, if there's outages, if there are security issues, if there are specific kind of thankless tasks that we require any application to do, from implementing monitoring, logging, error reporting. A lot of the things come really nicely bundled with managed services. And our stick has always been for customers to really focus on building really cool stuff. And in particular with generative AI, there's a lot of optimizing happening underneath the hood. The question is, do you want to spend time optimizing, or do you want to spend time building the next cool app? I think when you're working with someone like Google, you're working with engineers that are trying to optimize to the very bare metal. And why bother thinking about that when the difference between the first and second generative AI app is ginormous, right? Right. People don't know about Claude, but probably everyone knows about ChatGPT, and effectively their models are more or less the same. Mm-hmm. I think focusing your energies on building that application that'll have the wow factor with your consumers, your customers, is probably the most important thing you can do right now.
Got it. Talking about cost, right? So a question for Rodrigo. Whenever we are choosing any, a cloud solution or even BigQuery, right? Cost is one of the most important factors. I know Lin made it sound that we were focusing a lot on cost, and that's true, right? Every time we are choosing any cloud solution, the first thing is okay, how much is it going to cost us? And we know that BigQuery has this reservation-based pricing model, wherein organizations can reserve a set of computational resources, which is measured in slots, right? And it's not just about cost, but also about performance. And we always have to balance like cost and performance. So question for you is, are there any strategies that we can use to optimize slot utilization so that we can get consistent performance and cost efficiency at the same time?
Yeah, that's a good one. So I usually start with two principles in mind, right? One, the more you understand your usage, right, and the more you will be able to commit. The more you commit, the more you save, right? If you commit for a year, it's about 20%. If you commit for 3 years, it's about 40%. So let's say principle number one, you want to pay as little as you can on those slots. But then you have principle number two, you want to make sure that those slots are highly utilized, right? Because if you commit 1,000 and you're using them like 60%, you're wasting money. So that's the beginning, right, of the game. The second layer, right, that you have to look into is, okay, so BigQuery will evenly divide that compute power among everybody, right? So it's fair share for everybody in principle, but you can make it unfair. Right, so because you might have a business unit that needs to have a lot of power available on demand. So you can have baselines, and you can say, well, this business unit here will always have 1,000 slots available for them, and they will, other business units can borrow those slots. But if they need it, they will be preempted immediately, right? So that's a baseline, right? And I think BigQuery has a very interesting model that allows you to do that, and at the same time, the slots that are unused, they can be shared to other people, right? So you make that distribution uneven, and then you can see, okay, where you can allocate more power. The other thing that you can do is in this uneven, when you want to make the distribution uneven, is you can make lower priority workloads, and then you can cap that and say, hey, these workloads here, you will only have 100 slots, right? And you can even go further and say, by the way, you cannot borrow slots from other workloads, right? So there are controls that you can make. The key thing is to experiment, to keep an eye on your workloads and to try to maximize utilization. The third tool that you have, right? I talked about baselines. I talked about limiting the slots for one workload. The third tool is autoscale. Right, so BigQuery would allow you to have, okay, I have a pile of cache here that I could throw at a workload if needed, right? So you could scale up and you say, hey, I'll put an additional 500 slots on this workload if I need that during the week. But on weekends, right, I can scale down and then go back to a certain baseline, even zero, if that's the case.
So are those like set rules that you need to configure, or is something that can change based on the volume of the time?
They are rules that you configure, right? And you can configure at multiple levels. You can configure at the organization level. You can configure at a folder that has a collection of projects, or you can configure that at the project level. So you have a lot of flexibility there.
Got it. All right, thanks. Hendrik, like related to cost, do you want to add anything else? I know that we focused on that, and we actually tried to optimize quite a bit, and the end result was pretty good. Because I don't think I've heard this sentence before, that you started using BigQuery and it was really cheap. So can you expand on that?
Yeah, so like it was actually quite surprising because like as Lin explained, we actually started like premature optimizing because we thought, okay, that would be a problem. We can't use native tables.
Yeah.
And we also assumed that like if we create the files ourselves, like we can compress much better because we know our data. But then later we just tried it, and it worked really well because the compression like of like the native table, it's great. And I think like even the Google team is probably a bit disappointed about like the number tech that is coming out at the end.
We have a potential to scale a lot, so
yeah. So like on the other side, that opens up a lot of opportunities because if we now want to expand the use case like that, like we with the budget that we have, like there are a lot of options.
Yes.
So I mean, like what I found hardest about the cost is somehow like you can't really say before you start where you will end up. Like there are calculators that you can use, but basically to use the calculator, you need to know exactly like how many slots we will use for how long, and like you can't really know this before. So it really helps to like have a good understanding of your use case, maybe even have like data prepared that you can try out, and then just build a POC. Look at the billing data that you can get, like it's very granular, that you can export, and then look at like each query, like how much did it cost, do some analysis on this, and then, I mean, the Google tools, they make it really easy to build a POC. Like the threshold is very low. Just throw in your data, start working with it, look at the billing data. I think that's the best approach that we found.
Yep. I'll pause for any questions from the audience so far. I don't even know who has the mic, but Janelle? Okay, we have the mic here. All right, Soumya, go for it.
Hey, this is Soumya from DoubleVerify. I work alongside with Naved on a peer department leading the Pinnacle. Most of the Google folks know me too. So the question is around, since we're talking about the cost, and of course, Naved and I deal a lot with the cost and budgets, do you have like AI tools based on, for example, you're talking about the slots, and Naved team has a lot of trends or on how the data is used. But based on that, maybe your AI tools itself can say, hey, this hour of the day for this customer is when your volume is high or usage is high. And then you can scale up or down or suggest something like that. So which is really beneficial to the customers, which is, I don't know. I mean, I'm trying to combine AI with the cost, which is powerful for customers like us.
That's an excellent point. Autoscale in lots of ways, it looks at those patterns, right, to scale up and down. But the tool that will look at the usage and optimize, there is a UI in BigQuery that helps you model the slot usage. So you can take a workload and then do hypothesis modeling. Hey, what if I subtract 200 slots from this workload? What happens to my performance, right? So we have things like that. They're pretty sophisticated tools. But the exact thing that you're saying, I would point you to a partner. I'm happy to follow up later with that. We have partners that do that kind of analysis.
Thank you.
Anyone else from the audience? All right, Dennis, go for it.
Gentleman in the checkered shirt, your demo on Composer, you made it seem like it was very easy and straightforward to set up. Was it that easy? Or any teething problems getting that production?
Yeah, I'm trying to remember problems, challenges with Composer specifically. So yeah, I guess just understanding the constraints of some of the systems we're working with, and yeah, just understanding all the requirements and limitations and different limits. So we wanted to make sure that we could have enough throughput for the files. So we are running these processes every 5 minutes. BigQuery has a maximum number of files you can load per day. There's a maximum number of files you can load in a single BigQuery load operation. So yeah, just reading all the documentation, understanding that, and then actually running it and testing it and making sure that it all worked within the kind of constraints that we were expecting and hoping for and expect in the future. And so, yeah, it ended up working out okay.
It just so happens that Dennis is also James' manager. So, but this will not go in performance reviews. So, anyone else? All right.
Hello. Vladimir, DoubleVerify. Question for Google. We spend a lot of time working with external tables. And one of the things we notice is that partitions are not very well respected. So when we're querying for a specific partition, it tries to load the entire data set. Is that something expected?
No, it's not. I don't know if anyone would have details on that one.
So like, if I understand the question correctly, you mean the external table, you can only partition based on the date? But like the external partition is based on your like folder structure, right? Directory structure. So for us, you let's say you set up a date as your root, then you can have the hour at the subdirectory, then it's perfectly okay to partition based on the hour. So it's doable. So we've done that many, many times. Yeah.
From your side, do you see it actually respecting the partition and load files only from that specific partition?
Yeah. So you can actually like what we did was the partition, like you can enforce the filter. So if you don't send down the whale, like let's say data equal to this out to you cannot even run it. So this is one of the ways you can just control your costs, because a lot of times when people first experiment on the data, they say select star, for everything, right? And that's a gigantic query. It can easily cost you thousands of dollars if you have tons of data. But if you just enforce the partition, then they have to think about, okay, so they can still go around that and say, okay, well, date greater than last year, right? There's nothing can stop them to do that. But they have to really think about it. Oh, like I have to say, oh, this date, this hour, right? Then, the query will be much, much faster and much, much cheaper, right? So I think that's a very good practice. I can point you to the documents if you're interested, just ping me directly.
Yeah, that's the best thing. We can have follow-up sessions. It's tomorrow if you want. Okay, I'll continue with the panel questions. So this question is for Mehran. Serverless data processing is becoming a hot topic, right? How does Google see this trend evolving? And where does data flow fit into this landscape?
That's a great question. So Google's always been at the forefront of serverless, with BigQuery obviously, but especially when Dataflow came out in 2015, it was the only, I'd say, serverless stream processing product, right? Whereas other services required spinning up your own infrastructure, Dataflow was provisioning infrastructure on an automated basis. What you're seeing is other products actually adopting even more serverless patterns, right? So, like with Dataflow, yes, you don't have to get into the machinery, like literally the machinery of your workers, but what you're going to see is another kind of form of Dataflow where it essentially just you're submitting jobs into like this compute mesh, right? You're already seeing that with serverless Spark as part of Dataproc, and we just launched a managed Flink service that operates very similarly, right? When you look at other cloud vendors like AWS, AWS MSK, for example, managed service for Kafka, started off with just basically a kind of infrastructural serverless product, and then launched a truly serverless product where all you do is deploy. You don't even deploy Kafka clusters, right? You just write messages to, a blob of compute, right? Confluence the same way, and I think that's really it's a continuation of the trend I was talking about earlier, where the better we get at managing infrastructure on behalf of our customers, and the more complex it gets, right? Like this stuff is not getting easier. Outages and the capacity things that come up with running your own on-prem infrastructure, that isn't getting any easier. I'm thinking I see more and more customers adopting serverless products over self-managed or self-hosted products. To keep up with technology, to keep up with the latest updates, security updates, it takes a lot of, again, thankless work. Relying on vendors like Google or Snowflake or other people, I mean, they are doing a pretty gigantic service of serving as your SRE. For Google, I think you see more and more serverless products.
Right, cool. I'll switch up the tone a little bit and with an open-ended question, probably for Rodrigo. So you must have worked on like many client use cases. Can you share one of the most recent and exciting client use case?
Yeah, sure. I can share two because they're very different reasons. One, I come across a lot of large scale projects, and there was one recently that was interesting to me. So this was a weather data broker, right? So they sell weather data, and they process about 40 terabytes every 6 hours, which is not huge, but they do a lot of complex processing, pre-processing on that data, and they run inference on about 20 different machine learning models for data points across the globe, because they're global forecast providers. So I think it was interesting because of the scale. You need the discipline on the design to make things very efficient. The second one that comes to mind is not large scale, but I think it was interesting for other reasons. I was working with a Harvard expert that wanted to help middle school teachers give better feedback when students gave ideas, right? So this was
Student gave what? Sorry, I missed that.
When they gave ideas to solve a problem. So there was a lot of unstructured data. I ingested it all into BigQuery, lots of classrooms, lots of years, right? And we wanted to experiment with multiple prompts. And we used BigQuery ML to call Gemini, right, for each of those rows, each of those prompts, and then generate the reports. In the end, that was pretty interesting. I got to apply a little bit of learning sciences, right, to tweak those prompts. So I think it was a privilege to work on that project.
Okay. Next question, still for you. How many data engineers are here? Okay, how many of you love data engineering? We'll take that. We'll take that. So for data engineers who are trying to stay competitive, which skills and technologies you think are worth investing time into? And what do you think will have the most impact in the near future?
Oh, that's a good one. And my job description requires me to mention AI on this answer. Right? So, and all jokes aside, I mean, it's obvious to everyone that LLMs and Gen AI will take a chunk of data engineering, right? So data pipelines that are defined as code, people are already using that to produce some of this code, right? In Dataflow and BigQuery, you name it. Now, people, if you ask a business leader here at DoubleVerify or in any company, what can I do, right? They'll say, hey, help my subject matter experts get access to data. And this is the same answer of 20 years ago, right? So, but for a subject matter expert in business to get access to data, you need two things at least. You need a foundation of data, right? You need the pre-processing of data. That's not going to change. But what is changing now is the amount of skills that you need to access that data, right? So I think there's a shift. A lot of the visualization will be taken by Gen AI, a lot of the coding to prepare that data. And this will, I think, push the more complex questions to data analysts. So what kinds of skills will be interesting, right? I think you have to master the linking of these business abstractions, right? So lifetime value of a customer, or the gross and net margin, right? So these are abstractions. How do I get metadata on my foundational or on my data foundation so that the large language models can give more useful answers? So that's, I think, one thing, right? How to make those connections as a data professional. The second thing is, because I think the questions we're going to tackle will be more complex, I would invest in like data science thinking, not the traditional data science, not traditional machine learning, but like, okay, correlation, causation, the effects, right? So which variables have an effect on my outcome? So how do I make a case with data that can be presented to a subject matter expert, to a business leader? I think that's where things will go.
Got it. So you're saying that a lot of like narrow focus things will be, handled for you with AI in the mix, and now you have to take a step back and go broader.
Yes, AI will bite the easy stuff first,
Right.
right? Of course. So give me the average ticket size for the last 6 months. Easy, right? So if you have the right data foundation in place, AI can answer that today, right? Or an LLM, even data canvas in BigQuery could answer that kind of query, that kind of natural language question. But once you get into a little bit more complexity, you need either more data, more metadata, or more of this data science thinking that I'm talking about.
Right. We have time. We can go. All right, we're a little behind, but let's take 5 more minutes, I guess. Okay, there's an audience question.
Hello, I'm Rankasar. My question is for the lead of DoubleVerify. So given the usage of proprietary data in certain software, to what extent do you leverage the power of Gemini to ensure, taking into consideration that certain data needs to remain confidential?
So, I think like with our project, we don't really have a lot of unstructured data because we mainly control where we create the data and ingest it. So like that's not a problem we have to solve. But we definitely see use cases coming up where this could be relevant. So for example, like we are like one upcoming thing that is very important is basically like building targeting on the content level. And there we will actually start ingesting more metadata from our partners. And that will be definitely more unstructured than we have now. And I think that the challenge is a bit to bring down the scale, because like it's a lot of data. So we can't feed like billions of data points into Gemini or Vertex. Like it's probably not going to work, or it's like then tearing the whole company down with the cost. We don't want that. So I think like it's I think like there's always like finding the right tool for the job, like, and also like combining them. So using one tool to actually like aggregate the data, maybe pre-process it, and then at the right place where we see, okay, like if we apply Gemini here, then this will actually give us a huge lift, because we would have to develop like very complex application to handle this. Then go for it. I think that's a great thing. And like I think that having these options and actually like being able to apply the technology there and facilitate what we are doing, that's great. And I think that's actually like the really good thing about the development of the last years that we are seeing.
Any more audience questions? All right.
Let's go with this one. So since AI is pretty much everywhere and almost to the extent of we're not sure why sometimes, how much of your team is working on either new LLM models or using the existing Vertex AI stuff off the shelf and some modifications? Just a rough idea of percentages as to, integrations.
So I can't really say. Maybe you have someone else that could answer this, but I like because it's not our team that is doing that. But I know that like we have a team in measurement that's doing the classifications. They also like heavily utilize AI. I think like we built great solutions in-house that we use to classify, and we see that that's very cheap and actually scaling very well for us. We definitely run some experiments and POCs where we actually compare this with models that Google provides, and then it's always comparing. So like what can we gain from using the models? Like what can they provide that we don't have? But like in general, like if you ask for the percentage of people working on this, like it's not that much yet. But I see that coming. Like it will definitely get more in the next years.
Any more questions from the audience? All right. So, broader question, I guess, to everyone here, and the data analytics landscape, and that's evolving very fast, right? Are there any emerging trends or technologies that you're most excited about? And you have to answer this question without mentioning AI.
Can I
Fair
mention
enough.
large context windows? So there is a product called Notebook LLM. I don't know if you guys have seen that. The podcast that it produces became viral, right? You upload a bunch of documents and then it can produce a podcast or like a learning plan or a bunch of questions, right? So, and that's based on the premise that you put a lot of things on a large context window, and then you get interesting things, but you have references to the source, right? So it's grounded. It will point you to the exact sentence on the text that justifies that answer. So I think that's an interesting development, an interesting tool, and I wonder what that will do for data, right? How can we make large context entries that are data related to make the answers grounded but in data? I think that could be interesting.
You want to add anything else, Mehran?
This is maybe a little different, but there's been a lot of exciting advances in AR and VR as of late. I think Meta just announced new glasses that are not on the market yet, but definitely point to a future where we don't need our phones. I think what's really interesting about that is if you think about AI and ML, oftentimes it requires data, historical data, to make predictions about the future. Think about forecasting, think about recommendations based on a user's historical patterns. But if you are out in the real world interacting with things in real time, you're going to need, a lot more, relevant information in the moment, right? I don't think we've really seen the takeoff of real-time applications because we haven't had the use cases or technologies for it. But with AR, VR, where I think you'll have entire worlds being built in front of us, virtual worlds or AR, augmentations, that the speed of data and it being processed and the intelligence of it is going to be more relevant than ever. The idea that we actually do a lot of work with our phones, from taking it out, navigating into an app, entering things, and how many of those things could potentially be upended by just better intelligence and more contextual information. I think that's going to be a really interesting trend to see how data is used in that world.
And how about BigQuery? Like, what are some of the features or capabilities that you're excited about? Hendrik, even to us, like anything that you've found out?
So I think like to me, right? So my background before I joined DV, right? So I was like in Bloomberg, I was in Meta, right? So, but what I found was, I didn't use BigQuery before. So what I found was the BigQuery is so easy to just adopt. Literally, like go from like know nothing, become kind of in-house expert in 3 months, right? So what I found it's easy. It's like serverless like architecture allow you to do things so quickly. Like when in my previous job, when I tried to kind of build some machine learning model, so you have to kind of set up everything on-prem. You have set up a pipeline, takes like months to release. So I think to me, I'm very excited to like keep exploring the opportunity in the BigQuery. I think I'm especially interested in 2 things. One is the open table format, because I think that's a real challenge. I think, Databricks, Snowflake, everybody else is pushing to the Iceberg, but I think Iceberg still have some limitation in terms of how to interpret. So I'm really interested in see how BigQuery can kind of lead the market there, because I think, BigQuery is not there in terms of interoperability, even though it's very good, but I think there's still a gap. So that's one thing I really kind of want the BigQuery to provide. The other one is the BigQuery machine learning opportunity, right? So I think the generative AI is nice, right? You can do everything with that, but it's very expensive, right? Because we don't want to just find the problem because we have the tool, right? We want to look at what are the problems we solve. I think there's a lot of opportunity to just utilize those established machine learning model, more traditional classification, prediction. You can do a lot more, just embed that into the BigQuery. It's very easy to do that. You just use the SQL, and it's easy to maintain because you do things incrementally. You don't just jump there. You can just accomplish a lot with the existing technology. And then we've been pretty busy to keep up with the BigQuery new release, right? So every 3 months we find something new, and then we experiment, being very fantastic. We want to just make sure our system incrementally improve. Yeah.
And coincidentally, I can think of so many use cases where we can use ML in our projects, which we cannot talk about because of proprietary reasons. So, but yeah, there's a lot of opportunity. Rodrigo, and Mehran, do you want to add anything? You good? Any questions from the audience? I think okay, yes, we have one.
Yeah, hi, Tom Loral. You mentioned a few things about skills and development, and I'm trying to refer also to leveling up your data game. What would you recommend how to work with the subject matter experts? Should we leave them be and hope that AI is gonna help them to put some structure to the data, think about the direction, the potential benefits, or is there something for them also when it comes to leveling up their skills?
Yeah, that's an excellent question. I think it's not an either or. I think it's a yes and on this one. I think as data professionals, I think it's on us to help them understand what is possible, right? The art of the possible, the SME. But if the SME has no idea about how to use or how to tweak the prompt, right, or how to prompt the data, then the project will fail, right? So I think, especially where we are right now, a bit of hand-holding from the technology experts, right? So a little bit of learning from the tech experts to the business subject matter expert is key to success, right? On any kind of initiative that tries to give more access to this SME. Yeah.
Any more questions from the audience? All right, I think yeah, we can end here. We can end the session here if there are no more audience questions. All right, that's it. I would like to, yes, applause. Yeah, thanks a lot to the speaker and the panelists. Thanks Google team for collaborating with us and co-hosting our first ever tech meetup. Yeah, and I hope we have more of these, and hopefully we'll only get better. So, and thanks for all of you for joining us and staying back this late. I know we didn't do a great job with time management, but next time will be better. Okay?
Thank you.
Thank you.